Hello and welcome to the Slingshot channel, to the official first project in the rebuild workshop after the fire. Let me show you its features. So I now have lots of new storage space in these steel cupboards. There's my trusted old lathe, and I have a brand new workshop, a brand new workbench together with a new vise. Same old desk that I use, and still my wood stove, but now this is a stone wall that cannot catch fire. Everything is completely fireproof. The entire electricity is completely redone. So everything is new. So what is our first new project? Well, the idea is to make the invisible knife again. And there are invisible knives invisible to like X-ray scanners and so on. But like cold steel sells them with a material called ivory and so on. But they're also small. I want to have a big one. And I settled for the Midgard's knife, Odin's toothpick, because I love the design. The knife is sold out for now. So what I did is I printed it out on paper. And my intention is to make it in invisible materials. And I will make a wooden one, but I also have a new secret material that I think will revolutionize this market, since it's cheap and fantastic. I found out about it because the hardware store that I normally use to buy my wood was out of the thin wood that I normally use for making my prototype knives, like 4mm plywood. So I took this instead, which is something that, well, they call it a complete board. I think it's known as HPL, high pressure laminate, and it's basically paper that is kind of lacquered on the outside. And I thought it's just a cheap replacement, but in fact it's a lot better than wood. Huh, did I just say something is better than wood? Strange days. So this is a piece of the stuff. It's a 3mm type, but see, it is really flexible, almost as flexible as steel. It won't really break. It's really solid, very hard material, and you can saw it without any splintering on such. So this makes it, I think, really perfect for the task. I already made one just to test it. As you see, this is made from 4 layers of the stuff, and I made it in a way that is really comfortable in the hand, and the blade is kind of short because this was like a leftover piece. It looks a little bit like a tanto blade, and you see it is serrated somehow, and that is because I found that this was just like flint knives. So on a steel knife, when you really sharpen it and it really cuts well, then you don't cut with the blade itself, you cut with the burr. And that is why a lot of the simple sharpening tools just kind of erect the burr again, since the burr is so much thinner than the sharpest blade. So you're cutting with the burr and not with the blade itself. No, there is no burr or materials like this or flint, which is why normally you serrate, like a flint knife, you serrate it so that you have a sawing effect, because otherwise if you just sharpen it, it would not nearly cut as well as steel. So here we have a piece of cardboard, which is not easy to cut, even for a sharp knife. And this one here cuts into it fairly easily, see? Very easy job, not complicated. And even against the fiber direction, it still cuts reasonably well. So this is really a sharp knife. How does it cut into ballistic gelatin? Well, we'll find out. It cuts really well. There you go. Also, the blade is really flexible. It really behaves like much like a steel blade. I think, of course, it will not completely rival a steel blade, but it is really well made. This knife in the original steel version, which is sold out, but they're going to restock soon, so I put the link in there for you anyhow. This knife has a blade thickness of 1 centimeter. So 1 centimeter is really big. It's like 40 cal. Well, anyway, so this makes it really heavy and really a monster. So we want to have the same dimension. This means that we need a blade that is 1 centimeter in thickness as well. So we're not using like the 3mm type and then use 3 pieces. Instead, I got some 5mm type. Why? I'll just explain it to you. So this is the 5mm type, and as you see, it's lacquered on both sides. Now, if you glue 2 of these pieces together, what you get is, you get in the center, you get a double layer of the white material here. And this, for sharpening, makes it so much easier, since you only need to sharpen it until you see the white part coming through, and you do this on both sides, and you're absolutely guaranteed to have it sharpened just exactly in the middle, which is one of the hardest things if you make a knife by yourself, to sharpen it in a symmetrical way. Otherwise, the edge will be a little bit too far to the left or to the right, and this cannot happen with this. Okay, we now have transferred the whole design to the sheet, and now we will simply saw it out twice. Okay, now the basic shape is ready, and we're going to transfer this another time and saw it out another time, so that we have two exact same pieces. Okay, now I have these two, well, somehow identical pieces. I will have to grind them later on. But as you see, now I have the desired thickness of 1 centimeter. And now I'm taking super glue to put them together. And I'm using a super glue that gives you about 10 seconds of time to correct the position. So it's not instantly hardening, but like, you know, with a 10-second delay. This allows me to correct the position a little bit after I did this. And then I will press it in the vise to make it a really secure bond. Now we wipe off the excess glue, so we don't glue on our fingers to it. And then we'll smoothen out everything. And we will do this with a power file. But of course you can also do this with a regular file. Okay, now as you see, we have this beautiful white separation line right in the middle that we're now going to use for sharpening it. And for this I use a tool that's been sent to me a long time ago by a Russian company called TS Proof. I no longer do business with Russian companies because of the war, and I'm a big supporter of Ukraine. In any case, I still use the stuff that's been sent to me before the war because that is untainted. Otherwise I feel really sorry for these guys, because they can't do a thing about this, but in any case, here we go. Now this requires a two-step grind, because first of all, there is like this grind here, and I think that's probably born maybe a 9-degree angle, and then there's probably a 20-degree angle for giving it the a little bit of sharpness right at the edge. So we're going to do this in 2 stages from, of course, 2 sides. So as you see, I've clamped it in now into the machine, and I can actually swing this easily around to sharpen it from both sides. And normally you use these stones here that are clamped in so that you can use more finer ones at the end. But of course in the beginning it's way too much work, so I use my specially adapted little band, electric file here to do the first grinding, and then later on I will switch to these. So as you see, we now have our white line here in the middle, so that the edge really runs right through the middle of this. And now we will sand it down a little bit to give it a more like a small polished appeal, but it's already a fairly sharp knife. Okay, that looks pretty good now, I think. And it's also sharp. But what it now lacks is the fuller groove. And we will carve this in with the power FIREWOOD heads. So now we got our fuller. We will now need some scales, and we're going to do this from the same material, simply sketching the handle size again, and then we glue it on because we don't want nails. And here is the final knife. As you see, there is no metal in it at all. It's all basically paper and glue. And it is actually lighter, much lighter than the steel one, but it is heavier than wood because I also made a wooden one. Now this is the wooden one. This is made from plywood. As you see, the size is like identical, of course, made after the same model. And this one only weighs 150 grams, and this one is 230 grams, which is a very noticeable difference. But of course, it is basically the cut ability and also the edge, that stability that makes a difference here. This is so much more solid than the wooden one. Let's test the cutting abilities of this. Yeah, that's a deep, deep, deep cut. Very easy to cut through it. And this could just as well be a piece of beef or pork ready for the oven. Now if I try to do this with the wooden one, well, it also works. Wood isn't that bad at all. Now this one of course looks a lot more like steel than this one does. Can we paint it? Sure we can, absolutely. And then it's going to look even better. So this is the finished HBL board. This one is wood, this one is noticeably heavier, but this is undetectable and this is a little bit detectable because of the screws. But both of course are kind of nice. So our two knives, one in wood and one in HBL. And we're going to test it against various things. We have some vegetables, typical kitchen stuff. We have a nice steak, and we even have a piece of wood. So let's see how they fare. Starting with the vegetables. Cucumber and wooden knife. Absolutely no problem. Cucumber and HBL. No problem too. No problem. Then we have the bell pepper, wooden knife. Okay, it works, but it does require a little bit of pressure. HBL, much easier. This works great. Carrot. Not a challenge. This one, not a problem at all. Now the steak. Okay. Let's try the wood first. Absolutely possible, but not super great. Okay. HPL. Works like a charm. No problem at all. And then we have the fat part here, which is supposed to be much harder to cut, but it's actually even easier. No problem at all. And the wood definitely has a harder time cutting through. Rolfi, komm. Willst du mampfen? Na, komm hier. Ja, ja, ja. And now comes the biggest challenge, wood. So this is like very cheap wood, and this is of course plywood. So let's see how it fares. First we work on this very thin piece here. Yeah, that's not a problem, I can do that. Will it split it? Absolutely, not a problem at all. What happens when I hack it in here? Huh, interesting. No problem. Who would have thought? And the HPL? Yeah, absolutely no problem at all. Huh. I can see some scratches on the paint, but the material itself is absolutely pristine. Very, very nice. Now the real test. This is dry firewood and this is beech, so it's a hardwood. Let's see how it fares. Okay, the wooden knife first. Okay, I can now see dents on the blade. We'll switch over to the HPL. Ha! Folks, look at that. I'm splitting firewood. Like no problem at all. Now, I'm currently in the process of designing a new knife for Böker Plus, and this is supposed to be a follow-up for my folding Ulfberg line. So again, it will be a sword, a folding sword, but it is designed to follow in the steps of Narsil from the Lord of the Ring. So this means the sword that was used to hack off Sauron's index finger. And I made a first prototype from wood, and you can probably see that the finish isn't really great because it's wood, it's kind of rough. And also this was a little too small. So I made the next one, and the next one actually is larger, but it's also made from this new material. Now see how much nicer this one looks, how realistic. This almost looks like the real deal, don't you think? Well, this one looks rather flimsy. And also because it doesn't break off so easily, it doesn't splinter. Even the lock is so much more solid. I mean, this has no play, and it's a really, really good knife. You can do pretty much anything with this knife. So my conclusion is, these knives will never have the same sharpness as a steel blade, of course not. But they will still be sharp enough for most of the jobs that you need to do with it. I mean, you can't use it to carve wood, but splitting wood is really no problem at all. I actually have to say that I'm totally impressed by this, since they are not detectable. So these are very dangerous knives. These are serious weapons, but they are lightweight and they are not detectable by modern like X-ray scanners or whatever. And also I think they look pretty cool. Would you not agree? Anyway, I hope you like this because that's it for today. Thanks and bye bye.